Oh, I don't see a threat. I think it's most likely a natural object, but I do believe that we need to monitor it and verify that it doesn't release any objects that come close to planets.
When 3I Atlas flew past the sun's gravity bent its path by 16 degrees, and somehow the jet coming off the object stayed pointed directly at the sun through the entire deflection. And the only reason this worked is because two completely unrelated numbers happen to line up in a perfect 2-to-1-1 ratio that has about a 1 in 40,000 chance of happening randomly. And this is anomaly number 9. There are 6 more that had to happen before this just to set it up, and 6 more after. And when you stack the probabilities of all 15 coincidences on the same object, you start running out of ways to call this natural. So let me show you the math and why serious scientists are asking uncomfortable questions. The numbers that shouldn't match. So 3I Atlas made its closest approach on October the 29th at about 210 million kilometers out, and at that distance and speed the sun bent its trajectory by 16.4 degrees, which is completely normal physics that happens to everything. But when your path bends, everything attached to you bends with it. Your rotation axis, your surface features, your jets, all of it just got redirected by gravity. Before perihelion, there was this tightly collimated anti-tail pointing straight at the sun. And when the path got bent by 16 degrees, that jet should have swept across space because the whole object just got turned. If you're holding a flashlight and you turn 16 degrees left, the beam turns with you. It doesn't magically stay pointed at where it was aiming before because the beam is attached to the flashlight and the flashlight is attached to your hand. The beam has no choice. Except the jet coming off 3I Atlas didn't turn. It stayed pointed at the sun like someone was actively compensating for the bend. And the reason this appears to work is because of a geometric relationship that has no business existing. The anti-tail has an opening angle of 8 degrees. The gravitational deflection was 16.4 degrees, and 16.4 divided by 8 is 2.05, which is a perfect 2-to-1 ratio. Imagine the jet as a cone shooting out from one pole and the edge spans 8 degrees. When the trajectory bends by 16.4 degrees, the rotation axis shifts relative to the sun, but because the opening angle is exactly half the deflection angle, one edge of the jet cone that was pointing sunward before perihelion ends up overlapping with the opposite edge after. The geometry compensates for the bend, but this only works if the deflection angle is exactly twice the jet opening angle. If it was 15 degrees or 18 degrees, the compensation fails. The deflection depends on velocity, solar mass, and perihelion distance. The jet angle depends on sublimation physics, rotation rate, and ice pocket geometry. These are completely independent processes that have nothing to do with each other, and they lined up in exactly the right ratio. The odds are worse than you think. So the 2-to-1 ratio is weird enough on its own, but it's completely useless without the setup conditions. And according to the published analysis, there were 6 other geometric and physical things that all had to be true before this deflection compensation could even happen. And each one of these has its own probability of occurring randomly, and when you multiply them all together, the numbers get pretty uncomfortable. Anomaly 5 is rotation axis alignment. For the jet to maintain solar pointing through perihelion, the rotation axis of 3I Atlas had to be aligned to within 8 degrees of the sunward direction when it entered the solar system. And the thing about interstellar objects is they've been tumbling through space for millions or billions of years, getting nudged by gravitational interactions with other stars, getting smacked by micrometeoroids, experiencing outgassing events that change their spin. So by the time they arrive, their rotation axes should be pointing in basically random directions. The probability of a randomly tumbling interstellar object just happening to have its rotation axis aligned this closely with the direction toward the sun is estimated at about 0.5%, or roughly 1 in 200. Not impossible, but definitely not common. Anomaly 6 is where the active ice pocket is located on the surface. Before perihelion, the jet was wobbling back and forth with an 8-degree oscillation, and for this specific wobble pattern to occur, the base of the jet where the gas is actually coming from has to be positioned within 8 degrees of the sun-facing pole. If the active ice pocket was located anywhere else on the surface, like at the equator or near the opposite pole, you wouldn't see this wobble pattern. And the probability that the ice pocket just happens to be in this exact 8-degree cone at the sun-facing pole is again about 0.5%. Anomaly 7 is where it gets weirder. After perihelion, the jet continued pointing at the sun, which sounds great, except the object is now on the other side of its trajectory, and the side that was facing the sun before is now on the night side. So for the jet to keep going, there needs to be a second active ice pocket on the opposite pole. Not just anywhere, but specifically within 8 degrees of that opposite pole. And the probability that there just happens to be another ice pocket positioned in this exact location is, you guessed it, about 0.5%. Anomaly 8 asks how these ice pockets even got there. For ice to accumulate on the night side of an object traveling through the inner solar system, where temperatures are high enough to sublimate ice, the surface needs to stay cold enough for long enough to allow fresh ice deposits to build up. This requires the launch base to be really well insulated on the night side for months. On a typical natural comet, heat conducts through the body pretty efficiently because it's just rock and ice. So keeping the night side cold enough to accumulate ice while the day side is getting blasted by solar radiation is actually pretty difficult. It requires specific material properties we don't normally see. Anomaly 9 is the 2-to-1 ratio we spent last chapter on. The deflection has to be exactly twice the jet angle, which means arriving with exactly the right velocity and perihelion distance. If it was going faster or slower or approached closer or farther, the deflection would be different and the ratio wouldn't work. So the math: if each condition is independent, which they are because they depend on completely different physical properties, then it's 0.005 times 0.005 times 0.005. For the 3 alignment conditions, multiply that by the thermal requirements and the precise deflection angle, and you get a combined probability somewhere around 1 in 40,000. That's the estimated odds all these conditions just randomly lined up. And there's another problem that doesn't even show up in the calculation: the collimation itself. Normal cometary jets diffuse pretty quickly after leaving the surface because gas molecules are moving in random directions, colliding with each other, spreading out due to thermal expansion. The cloud just disperses. But the anti-tail jet coming off 3I Atlas stayed tightly collimated for over 500,000 kilometers, which is farther than Earth to Moon. It stayed focused like a particle beam across interplanetary distances. And this is happening while the object is executing complex tumbling because the brightness varies on a 16.16-hour period, but the jet wobble shows a 15.48-hour period, which means 2 different rotation rates happening simultaneously. It's tumbling in multiple directions at once. So we've got an object that maintained perfect solar pointing through a 16-degree deflection by hitting a 1 in 40,000 coincidence, while keeping its jet focused like a laser across distances that should cause it to diffuse, while tumbling in 2 directions at the same time. And there are 6 more weird things this object is doing. This is just one of 15. The perihelion deflection geometry is anomaly number 9 in a list of 15 documented unusual behaviors. And when you start looking at the complete list together, the pattern gets really hard to dismiss as just a weird comet that happened to do a bunch of unlikely things. Anomaly 10 is where 3I Atlas came from. When astronomers backtrack the trajectory through space, accounting for gravitational interactions with every star it might have passed, The object appears to have originated from a direction that's coincident with the famous WOW signal from 1977 to within about 9 degrees. Now, if you're not familiar with the WOW signal, here's the quick version. In August 1977, astronomers at Ohio State University were using the Big Ear radio telescope to scan for unusual signals, and they detected this incredibly powerful narrowband transmission that lasted exactly 72 seconds from Sagittarius. The signal was so unusual, the astronomer analyzing the data literally wrote "wow" on the printout, which is how it got its name. And what made this really interesting is it was transmitted at 1420 MHz, which is the hydrogen line frequency. And hydrogen is the most abundant element in the universe, so if you were an alien civilization trying to send a message that any other technologically advanced species would recognize, 1420 MHz is probably the frequency you'd use because anybody studying radio astronomy would be monitoring that frequency. We've been searching for another signal like it for almost 50 years and found nothing. And 3I Atlas came from that direction. Anomaly 11 is the gas composition. When scientists analyzed the spectroscopy of the coma, they found it contains way more nickel than iron, which is really unusual because nickel and iron are both formed together in supernova explosions, and they're usually found together at pretty consistent ratios. But the nickel to cyanide ratio, measured in the 3I Atlas plume, is orders of magnitude larger than what you'd find in normal comets, or even in 2I Borisov, which was also an interstellar comet. The only time we see nickel ratios like this on Earth is in industrially produced nickel alloys, where we've specifically refined and separated the metals through deliberate chemical processes. Anomaly 12 is water content. The plume contains only about 4% water by mass, and this is huge because water is usually the dominant component of comets. It's what makes them bright and gives them big tails. Normal solar system comets are typically 50 to 80% water ice. Even 2I Borisov, which came from another star, had way more water than this. The plume around 3I Atlas is mostly carbon dioxide and other volatiles with just a tiny fraction of water, and that ratio is basically completely backwards from what we see in natural comets everywhere else. Anomaly 13 is the nucleus properties. Based on observations, 3I Atlas appears significantly more massive than either 1I Oumuamua or 2I Borisov, and it's moving faster than both of them. And the problem is, interstellar space is not empty. There's dust floating around, there's gas, there are micrometeoroids, and over millions of years of traveling through this stuff at high velocity, objects get eroded and broken apart. The bigger and faster you are, the more likely you collide with something substantial enough to damage you. So the fact that 3I Atlas is both larger and faster suggests either it got extremely lucky and avoided any significant collisions during its entire journey through the galaxy, or it's made of something exceptionally durable that can withstand repeated impacts, or it hasn't actually been traveling through space for as long as we think. Anomaly 14 is the extreme negative polarization of light scattered from the coma. When sunlight hits the cloud of gas and dust and bounces toward Earth, the way that light scatters tells us about the physical properties of the particles doing the scattering. And 3I Atlas produces this very unusual negative polarization signature that's unprecedented for any comet we've ever observed. Every other comet we've looked at, including 2I Borisov and every solar system comet, shows positive polarization. The only way to produce this kind of extreme negative polarization is if the particles in the coma have very specific optical properties we don't see in normal cometary dust. And Anomaly 15 is what happened as the object approached Perihelion. 3I Atlas brightened faster than any known comet, and at peak brightness, near closest approach, it was actually bluer than the Sun itself. And this is completely backwards from normal behavior because typical comets get redder as they approach the Sun. The reason being, dust particles in the coma scatter red light more efficiently than blue light. So more dust means redder appearance. But 3i Atlas went the opposite direction and turned blue, which suggests the coma was dominated by gas that emits blue light when excited by solar radiation, rather than being dominated by light-scattering dust particles. So when you look at this complete list of 15 anomalies, each individual one might be explainable as some kind of natural process we just haven't encountered before. Maybe there's a perfectly reasonable explanation for each one. But when you start stacking all 15 together on the same object, the combined probability gets really small and you run into a problem. This is where researchers like Avi Loeb bring up what he calls the Trojan horse hypothesis. And the basic idea is if you were an advanced technological civilization wanting to send a probe to explore other star systems, you probably wouldn't build something that looks like a shiny metallic spacecraft, because that would be obviously artificial. Instead, you could take a natural object like a comet or asteroid and hollow it out, or plant technological devices inside it, or mount them on the surface, using the natural ice and rock as camouflage. From a distance, it would look like a normal comet surrounded by gas and dust from sublimating ice doing comet things. But up close, you might discover the gas is being released through artificial vents, or the trajectory is being adjusted by small thrusters, or the surface is covered in sensors collecting data about the solar system. And here's the uncomfortable thing. We cannot rule this out based on current evidence. Every single piece of data is technically consistent with both a very unusual natural comet and a technological object deliberately designed to look like one. Who's watching and why it matters. So this isn't internet conspiracy. The papers are by Avi Loeb, who's a Harvard astronomy professor, former department chair, founded the Black Hole Initiative, discovered gravitational lensing, published over 700 peer-reviewed papers, one of the most cited astronomers alive. When he says we need to take technological origins seriously, people listen because this is the guy who literally wrote the textbook on astrophysics that half the astronomers working today learned from. And he's got nothing to gain and everything to lose by putting his reputation on the line for something this controversial. And he's not just writing papers. In the Perihelion deflection article, Loeb says his New Year's resolution is to keep looking up at 3i Atlas during his morning jogs starting December 19th, 2025. He's literally watching the sky every morning and coordinating with observatories worldwide collecting data during close approach. And this isn't some casual hobby. This is a coordinated international effort to catch this object at its closest point to Earth, when our telescopes can actually resolve details beyond just the fuzzy cloud of gas. The International Asteroid Warning Network is running a planetary defense campaign collecting spectroscopy, photometry, trajectory data, composition analysis. Once public, Loeb will update the Loeb classification scale, which ranks interstellar objects by unusual characteristics and probability. They're natural. Right now, 1e Oumuamua ranks high because of unexplained acceleration and cigar shape, but 3i Atlas might rank higher once new data is analyzed. And the close approach observations are going to answer some very specific questions, like, can we detect any structural features in the nucleus beyond the gas cloud? Does the jet collimation behave like natural sublimation models predict, or does it do something our physics can't explain? Are there spectroscopic signatures that are fundamentally inconsistent with thermal sublimation of natural ices? Because these aren't philosophical questions. These are testable hypotheses that will constrain which explanation actually fits the data. 3 options. 1. 3i Atlas is natural, and we witnessed a statistical outlier where 15 anomalies aligned by chance. 2. There's physics we don't understand yet. Maybe comet formation in old stellar regions produces these properties. Maybe sublimation creates collimated jets under conditions our models miss. 3. It has technological components, modified natural object or artificial probe with accumulated ice. The answer matters because option 1 means we saw something incredibly rare but ultimately just a cosmic fluke. Option 2 means we're about to discover fundamentally new physics that changes how we understand comets and maybe planetary formation. And Option 3 means we're not alone, and someone out there built something and sent it here. So what do you think? 1 in 40,000 coincidence? New physics? Or something else? Drop it in the comments. Thanks for watching.